Okay, this chapter is the second one of our unit on the cardiovascular system because last chapter was just the blood. When you look in your book at this chapter, it's humongous, but a lot of the chapter is devoted to naming the blood vessels, and that's something we'll do in lab. So this is in a way like the skeletal system chapter and the muscular system chapter in AP1, where a bunch of it is just some anatomy of naming, and you won't be tested on that in lecture. Okay. We're going to focus on the heart and the basic blood flow in the body without naming some individual blood vessels. But we'll look at the different categories of blood vessels. So today we're going to focus on the heart. And you can see, we have about 5 liters of blood in the body. But in the course of a day, your heart pumps 7,000 liters. That's just phenomenal how many times the blood is flowing through the body. You don't have to know these numbers here. But later in the chapter, we'll be looking at the names of the categories of blood vessels. But when the heart pumps, the first vessel the blood gets into is called an artery. Arteries are blood vessels that carry blood away from the heart. But they branch into smaller ones called arterioles, which branch into smallest blood vessels called capillaries. And the capillary level is where all the exchange with your tissues takes place. And then from there, the blood moves to venules, which empty into veins that carry blood to the heart. So arteries carry blood away from the heart. Veins bring it back to the heart. Okay. And so all of those blood vessels plus your heart is called your cardiovascular system. So here you can see pictures, nice little pictures of it, the heart and the blood vessels. When we look at the heart today, we're going to see its action as a pump, but it's basically a double pump. One side is pumping blood to the lungs. The other side is pumping blood everywhere else. Okay, and so those two places and the circuits involved in those, they're referred to as the pulmonary circuit and the systemic circuit. And as we look at the heart, this will make more sense. Okay, this is just putting the words out there for you, but you'll see what we mean. If you think about it, we are very multicellular organisms, aren't we? And we are so big that, let's say, if your heart is pumping oxygenated blood to your tissues, the reason it has to go back to the heart to then be pumped to the lungs to get more oxygen and to give up CO2 is because there's not enough pressure in the blood, because we are made up of so many blood vessels. So it can get back to the heart, and then the heart pumps it to the lungs to pick up oxygen, and then it comes back to the heart. There's not enough pressure in it at the lungs to go anywhere else except the heart, and then it's repumped to the body. So that may not make sense with me just talking about it. I know I didn't explain that real well, but as we go through the heart and look at all the different parts and follow a drop of blood through it, you'll see these two circuits in action. Okay, so here is an overview, and on the left side of the heart, the left side of this heart is the blue area, which means that heart's left side. Excuse me, I said that wrong. The left side of the heart is the red area. It's that heart's left side, not yours as you're looking through it. Okay, so the left side is the red area, and that it's red because that represents the fact that it's carrying oxygenated blood. And then the right side of the heart is what you see in blue. That's carrying deoxygenated blood. So we're going to watch a drop of blood. Let's say it's deoxygenated. It's coming from your tissues, and it's going to empty into one of the 4 chambers of the heart. The 2 upper chambers are called the atria. The 2 lower chambers are the ventricles. But anyway, we'll see that in your notes in just a moment. But the blood now is deoxygenated, and it moves to this lower chamber, which is a true pumping chamber that pumps the blood over to the lungs. So now it gets to the lungs where it gives up its carbon dioxide and picks up oxygen. So now it's becoming oxygenated, and it goes into this chamber from each lung where it's moved down, and then pumped out to the body. And so where it's pumped to the body, that's the systemic circuit that gets it back here. And then this is the pulmonary circuit. So do you see that? Okay, I'll have a video in a little while that shows that too. But these circuits are running at the same time while the left side is circulating the oxygenated blood, the right side is circulating the deoxygenated. Okay, it all occurs simultaneously. So if we look at it, it's located in the mediastinum, which is in between your lungs. It sits on top of your diaphragm, and it has 4 chambers in it. The 2 at the top are called the atria. So you have a right atrium and a left atrium, and then the 2 at the bottom are the ventricles. You have a right ventricle and a left ventricle. Okay. And so here you can see the heart looking at it from the front, and on the upper left, what's highlighted in red is the right atrium, and then the left atrium is on the upper right side of the picture here, and then the lower right side of the picture is showing the left ventricle, and then over here on the left side of your picture, I'm getting lefts and rights. That's very confusing, I know, but you can see the right ventricle. Okay, you can see that highlighted. If you want to go back and pull this up in your PowerPoints, in Canvas, then you can see the colors. But okay, and then here you can see its location in the mediastinum, and it's sitting on top of your diaphragm. Okay, and then you can see it's very well protected by the rib cage. Notice that it's not straight up and down. It angles the apex, the bottom end of it is the apex. See how it angles to the left a little bit? Okay. Now, before we get into the details of the parts of the heart, we're going to look at the sac around the heart. That sac enclosing the heart is called the pericardium. And it's got 2 layers to it. The sac itself has 2 layers. It has the outer fibrous layer, and then the lining of it is called the parietal pericardium. Okay, remember in A&P 1, we talked about the parietal and the visceral pericardium, and I had mentioned to you, if you had me for A&P 1, that the parietal pericardium lines the sac around the heart. Okay. The sac itself is made up of fibrous tissue. Okay, that would be the fibrous pericardium. Okay, then the visceral pericardium is not part of the sac. It is the outer layer of the heart's wall. But they're continuous with each other. Like on if you look at it like here. Okay. And you look at the magnified view, there's the fibrous pericardium, and then there's the parietal pericardium, and see how it loops over to go onto the surface of the heart to be the visceral pericardium. Okay, which is not a big deal on your test. Just know the visceral pericardium is on the surface of the heart. It's the outer layer of the heart's wall, and then the parietal pericardium lines the sac around the heart, and the bulk of that sac is the fibrous pericardium. Okay. Okay, now if you took a plug out of the wall of the heart, you can see that there are 3 layers in the wall of the heart. Lining the chambers is the endocardium. So I'll draw it in blue. So here you take a plug out. Here's the endocardium. Okay. And then the muscle layer where you have all this cardiac muscle is the myocardium. And then on the outer surface of the heart is the epicardium. But the epicardium, remember, that's the same thing as the visceral pericardium. The epicardium and the visceral pericardium are the same thing. Okay? It's just if we talk about it as a membrane around the heart, it's called visceral pericardium. If we talk about it as a layer in the heart's wall, we sometimes call it epicardium. But they are the same thing. I'm sorry that there are 2 terms for the same thing. And then on this, where it took the plug out, this picture's not really good because it's showing you it's taking a plug out, but it includes the fibrous and the parietal pericardium right there, which is not shown over here. But anyway. Okay, now what we're going to do, if you look at the next few slides, you see a listing of the chambers, the valves, some of the blood vessels that are associated with the heart, connected to the heart. Okay, so uh, what I'd like to do is follow a drop of blood through the heart, starting with the blood entering at the right atrium. And I'm going to follow it through the right side to the lungs, over to the left side, and then out to the body. And as I do, I will be talking about all these detailed little structures associated with the heart. So you might want to move on to some of these other slides in your notes. Okay. So first of all, when you see this sectioned view, do you see how the two sides of the heart are separated by what we call a septum? You have a septum between the ventricles, and that may not be in your notes, but you see it as you read in your book, or you may hear me talk about the interventricular septum. There's also a septum between the atria called the interatrial septum. That makes sense, doesn't it? Okay. All right. And so the two sides are completely divided. So the blood on the left side does not ever mix, hopefully, with the blood on the right side. Okay. All right. So let's follow. We're going to follow this drop of blood. And we're going to start with the blood entering the right atrium. So here's the right atrium. Okay. And the blood comes in by way of a blood vessel that's draining the upper part of the body. It is called the superior vena cava. It's a vein. Remember, veins carry blood to the heart? Okay, it's a vein. And then draining the torso and the lower part of the body, like the legs, would be the inferior vena cava. And that drains into this chamber called the right atrium. And then as the blood moves into the right atrium, just because of gravity, it trickles down into the right ventricle. But as it does, it goes through our first valve. We're going to see 4 valves in the heart. And the purpose of the valves is to prevent a backflow of blood. They don't push the blood anywhere. They just prevent it from going backwards. Okay? All right, this first valve we're going to encounter has a couple of names. You can call it the tricuspid. It's got 3 cusps. Or another name for it is the right atrioventricular valve. AV is atrioventricular, between an atrium and ventricle on the right side. Makes sense, doesn't it? All right, tricuspid valve. It's hard to tell on this picture that it has 3 flaps, but it does. If you think about like the top of a pie that has a crust on the top, and if you cut that crust into 3 equal pieces, you know how each one would look somewhat like a triangle? That's kind of like the tricuspid valve. All right, and so watch. If blood goes from the atrium to the ventricle, it pushes the valves down against the wall of the ventricle so blood can pass through. But at the apex of each of those valves is a little string-like structure. You see it in the picture. See these tiny little strings? They're tiny little ligaments. They're called chordae, little tiny cords of fibrous tissue. Chordae tendineae. Okay? And they don't stretch because they're fibrous tissue. All right, but as that valve collapses down against the wall of the ventricle, if the blood starts backing up in the opposite direction, like when that ventricle contracts and when it fills up with blood, watch. The valve comes back like to the top of the pie crust, but because of those strings, the chordae tendineae, it can't go further than that, so it can't flap up in the upper direction. So do you see how it prevents the blood from going back up into the atria? Okay, so that's our first valve, is the tricuspid valve. Okay, so now that blood is down in the right atrium, it's down in the right ventricle, and as it fills up with blood, the tricuspid valve closes, and then when the myocardium contracts, right here, it contracts, that's going to force the blood into the only other place it can go, which is into this artery. Arteries carry blood away from the heart, and it's called the pulmonary trunk. The pulmonary trunk, which branches into the 2 pulmonary arteries. Okay, you might notice it's blue in color, which represents deoxygenated blood. you may have thought that arteries carry oxygenated blood and veins carry deoxygenated. That's true if you're talking about arteries and veins of the systemic circuit. But this is an artery of the pulmonary circuit. It's an artery because it does what? Carries blood away from the heart, but it happens to have deoxygenated blood in it because it's coming from the right side of the heart. That's the reason it's going to the lungs, to pick up some oxygen and give up its CO2. But anyway, that's the pulmonary trunk. Pulmonary trunk. It's okay for me if you call it pulmonary artery because it quickly branches into the left and the right pulmonary arteries. At the base of it is our second valve, and it is called the pulmonary. Here it just says pulmonary valve, but a lot of times you refer to it as a pulmonary semilunar valve, which is like half moons. Pulmonary semilunar valve. Do you see how it's got three little pouches? Think of these as kind of like pockets that line the base of that artery. And if blood moves this way, they collapse, like upside down parachutes, sort of. They will collapse. But if blood tries to back up, they get filled up, filled up, filled up, and as they fill up, they come together and it closes it off. Okay, so they act like this. Okay, so that's the pulmonary semilunar valve, also called the pulmonary valve. It's located at the base of the pulmonary trunk. Okay, so now the blood's over here in the lungs, and it gives up its carbon dioxide, picks up what? Oxygen. And now it's got to go to the left side of the heart, and it goes into pulmonary veins. These are the only veins that have oxygenated blood. There's a pulmonary vein. But they empty the blood into the left, what I've circled right here is the left atrium. So the pulmonary veins, they're veins because they carry blood to the heart, but they're carrying oxygenated blood to the left atrium. Okay? And then the left atrium, the blood in there acts like the blood does in the right atrium. It trickles down into the left ventricle, passing through another valve that has a little chordae tendineae on it. But this valve only has two flaps rather than three, so it's called the bicuspid valve. So that it would also be called the left AV valve, atrioventricular. But the most famous name for it is the mitral valve. I know they all have a bunch of names. Mitral valve. Okay, but it acts just like the tricuspid does in that it has the little chordae tendineae, it's the little flaps, and as the blood flows from the left atrium into the left ventricle, they flap down against the wall of the left ventricle, but then as the left ventricle fills with blood, they come up and snap shut. Okay, and so then when this left ventricle contracts, the blood can't go back up into the atrium. Okay, and so the only place it can go is into this blood vessel, which on this left side picture, you don't see the connection. But if you look at the picture on the right, look over here. Do you see how the pulmonary trunk has been removed where it connects to the right ventricle? And so you see underneath it. And so now you can see the blood moves up into this blood vessel. This blood vessel right here is called the aorta. Okay. At the base of it is another valve that is like a semilunar valve, just like in the pulmonary trunk. But it's called the aortic semilunar valve. But it has three little pockets, okay, that collapse and fill up, collapse and fill up. So now that blood is oxygenated, and now it goes to the aorta to go through the systemic circuit. And the aorta arches over, goes down behind the heart, goes down the thorax and the abdomen, and it forks off into the pelvis and in the legs. And this upper one has branches that go to the head and the shoulders and the arms. So it's carrying blood to everywhere else in the body except the lungs. So it's carrying it everywhere else. Okay. Some of it is getting to the lungs too because it's got to have oxygen. The cells have to have oxygen. But anyway, but that's the systemic circuit, and gives up blood to all your tissues, gives up oxygen to your tissues, picks up CO2, and then the whole thing starts back over again, comes back in by way of the vena cava. Okay? If you can follow the course of a drop of blood through the heart like I did, you'll be able to answer several questions on the test. For example, Where does the blood come from where is it coming from when it enters the left atrium? It's coming from the lungs, but specifically what's connecting to the left atrium? It would be the pulmonary veins. Pulmonary veins. Where does the blood flow when it leaves the left ventricle? Through the aortic valve into the aorta. What's the name of the valve between the right atrium and the right ventricle? The tricuspid. So if you can follow the drop of blood through, naming all the parts along the way, that'll help you a lot. That is a hugely significant thing to be able to do in A&P. I remember when my daughter was in nursing school, she called me one day and said, "Can you go back over the path of the blood through the heart?" They expect us to know that. Do you have a question? The mitral valve is the kind of common everyday name, but it's also called the bicuspid, and it's also called the left atrioventricular valve. I hope I have that in your notes. Like here are the chambers, and then here are the valves. Okay. They prevent the blood from going in the wrong direction. So the AV valves, the atrioventricular, the right AV valve is called the tricuspid. The left AV valve is called the bicuspid or the mitral valve. Okay? Pardon me? In respiratory therapy programs, definitely you need to know the action of the heart because it directly affects what's going on in the lungs. Okay? Because of that pulmonary circuit. Okay? All right, and then here are the semilunar valves at the base of the pulmonary artery or pulmonary trunk and I should say trunk there, and the aorta. Okay. The whole purpose of these valves is to prevent a backflow. Because imagine if, let's say, if the bicuspid valve didn't work adequately and the blood was able to flow back up into the into the left atrium, that means you don't get enough blood going to your aorta to supply your tissues. You ever heard of a heart murmur? That's a faulty valve, and that's when the blood is trickling back in the wrong direction. So that means your blood's not flowing where it needs to go, and you may not get enough oxygen to your tissues. So, if somebody has a hole in his heart, that's in the septum, and that means oxygenated and deoxygenated blood can mix. Now, before you're born, you have a hole in your heart. You have a hole in the interatrial septum, and as soon as blood goes into the right atrium, it's already oxygenated because in that fetus, the oxygenating is occurring at the placenta, which is part of the systemic circuit. So it's getting oxygen from the mother's blood. And so when it gets to the left side of the heart, it's already oxygenated. So that little fetus doesn't need lungs. And so the blood in the right atrium can just move over into the left atrium to go to the body systems. But before you're born, that hole is supposed to close up, but sometimes it doesn't when a newborn. And sometimes there's an intraventricular opening. But they can surgically, sometimes medically, just with medicine, it will close. But sometimes they have to have surgery in it. But okay, so this explains the valves a little bit more for you on their location. So just to help you out, you've got lots of tables in your book that just help condense your notes a little bit that are helpful. This isn't anything in addition to what I've already typed. It's just a repeat of it. Okay. Okay, now I like this view. You can actually see some of these flaps or cusps of the tricuspid valve, and you can see the little chordae tendineae up on the upper left picture. You can see that. And then the picture that you see on the right is a section, it would probably be like on this heart, right, I don't know how it would, something like through there. But anyway, you can see the location of all four valves. They're all on one plane, and that's pretty neat. So here are the semilunar valves. So they look like little pockets. And then here's I guess this looks like tricuspid, and that's the bicuspid. Okay, so I've repeated on here the blood flow through the heart, like I did on the picture. So it's right there for you. And do you see it starts at the superior and inferior vena cava, into the right atrium, through the tricuspid valve, into the right ventricle, through the pulmonary semilunar valve, into the pulmonary trunk, and da 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 da. See that there? And on the special note, remember, arteries always carry blood away from the heart, regardless of whether that blood's oxygenated or deoxygenated. Arteries carry it away from the heart, and veins bring it back to the heart. Okay? And then if you didn't get the flow, here it is again. Okay? The flow is very important. Okay? If you can visualize a heart, draw it out yourself. And have arrows all over it, you know, as you course that drop of blood. Okay? Important. And there's other pictures. It's the same picture I just went through. I just put it here so you can see that again. Okay? It is very important. Have I stressed that enough? Yes. Okay. We just saw a real picture of what's called the skeleton of the heart, where it showed a section through a real heart where you saw the location of the valves. There's fibrous tissue that encircles the opening where the valves are, and that fibrous area is referred to as the skeleton of the heart, but it helps keep that pathway open so that the blood can flow through. That'd be very important, wouldn't it? Okay. All right, here's this little video. It's not going to go through every detailed structure, but it gives you a really good view of the difference in the pulmonary circuit and the systemic circuit.
The cardiovascular system is divided into systemic and pulmonary parts. The systemic circulation carries blood from the heart to tissues of the body and then returns it to the heart. Oxygen-rich blood is pumped from the left ventricle into the ascending aorta. The aorta then makes an inverted U-turn to form the aortic arch, which gives rise to branches that supply the head, neck, and upper limbs. The aorta continues posterior to the heart as the descending aorta, which travels through the thoracic and abdominal pelvic cavities. It supplies the organs of these cavities and the lower limbs. In the systemic capillaries, oxygen is exchanged for carbon dioxide, resulting in oxygen-poor blood. The oxygen-poor blood enters the right atrium via the superior and inferior venae cavae. The pulmonary circulation carries blood from the heart to the lungs for gas exchange and then returns it to the heart. Oxygen-poor blood is pumped from the right ventricle into the pulmonary trunk. The large pulmonary trunk divides into the right and left pulmonary arteries. These arteries transport blood to the right and left lungs. In pulmonary capillaries, carbon dioxide is exchanged for oxygen. This results in oxygen-rich blood that then flows through the 4 pulmonary veins and enters the left atrium.
Okay. Would it surprise you? Well, no. I'll come back to would it surprise you? Just a minute. I want to show you something. Let's look at this. What is the myocardium? That's the heart muscle. That's one of the 3 layers in the wall of the heart. All right. And you have all of those 3 layers, epicardium, myocardium, and endocardium, making up the wall of each of the 4 chambers. Okay. I want you to look at the wall of the right atrium. Let's say there's the myocardium of it. Here's the myocardium of the right ventricle. Which is thicker, the atrial myocardium or the ventricular myocardium? Which is thicker? Ventricular. Why do you think that's the case? I think you have the right ideas. Because the ventricles are pumping the blood where? Out of the heart. The atria, a lot of that blood comes down just through gravity, but then the atria do contract to get the remaining part down. but it doesn't have to go very far. Therefore, the atrial walls don't have to be as strong as the ventricular walls. Ventricular walls have to pump enough to get the blood out of the heart. Compare the right ventricle's myocardium to that of the left ventricle, which is thicker. Left, really thick. Why do you think that's the case? It's not because it has, not directly because it has oxygen. Where is the blood going? The blood in the left ventricle has got to go even all the way up to your head, out to your fingertips, to your big toe. Whereas the right side is pumping in how far? Just to the lungs, which is in the same major body cavity, right? In the thoracic cavity. So it doesn't have to be as strong. Structure determines function. See that? The area with the thickest myocardium is going to pump with the most force because the blood's got to move further. It has to have more pressure in it. Later on in the chapter, we'll talk about blood pressures, and it all has to do with the action of the heart. Okay, so now let me go back to that statement I was about to make. Would it surprise you if I told you that even though there's always some blood inside the heart, either in the atria or the ventricles, and one side always has oxygenated blood in it, the heart cells don't get their oxygen from the blood that's inside the heart? Think on that. The heart cells, which need oxygen like all the other cells of the body, they don't get their oxygen supply from the blood inside the heart. They get their oxygen supply like most all the other blood cells of your body do, except those of the cornea. They get it from blood capillaries. And those capillaries are on the surface of the heart because capillary walls are thin enough for things like oxygen and glucose to move in and out. All right. So when we talk about the systemic circuit, that's that blood that's moving into the aorta and it's branching everywhere. The aorta has tons of branches. It has branches that in turn branch to go to all the tissues of the body. The first branching coming off the aorta is little arteries that go right onto the outer surface of the heart. And they are called the coronary arteries. They're part of a coronary circuit, which is one circuit within the systemic circuit. You have a renal circuit, a hepatic circuit. You have it to various organs. But here's the first one that goes onto the heart itself. It's called the coronary circuit. So what you're seeing on this picture, here's the aorta, and they have cut a plug out of it so you can see the valve at the base of it. So that's that aortic semilunar valve. Just as the blood gets through that valve, the first opportunity it has to get out of the aorta is right there or right there. This first one I drew is the right coronary artery. The second one is the left coronary artery, which goes underneath the pulmonary trunk, and there you see it right there on the surface of the heart. So on this bottom picture, here's the right coronary artery. There's the left one. It's coming up underneath the pulmonary trunk. So one supplies the right side, one supplies the left side. But those arteries in turn branch into smaller ones, and ultimately you got this whole capillary network that you won't see a picture of. But that's where all the gas exchange and nutrient exchange takes place with the heart muscle cells and the blood. Okay? So these next few pictures are going to show some of that. So we're going to look at some of the blood vessels, not all of them, but we're going to look at the main blood vessels of what we call the coronary circuit. And then we'll come back to these other terms. Okay. So you've got two coronary arteries. You have a right one and a left one. And for this test, you're going to name the two main branches of each. So I've got them listed here, the A, B. Those are the circumflex anterior interventricular arteries. Those are the two branches of the left coronary, and then the two branches of the right coronary are the marginal and the posterior interventricular. Where it says AV sulcus, remember in the nervous system, in the brain, a sulcus was a shallow groove? Okay. In the heart, you have a groove between each atrium and ventricle externally. And that's where when it says in that sulcus, that's where it's located. Okay? That's all that means. But, okay, so, and And then just hold this thought on cardiac veins. Once the blood gets through the artery system and gets to capillaries, gas exchange takes place. Then it's got to move into veins, and collectively they're called cardiac veins. I don't know why they're not called coronary veins, but they're called cardiac veins. And they empty into one super large one on the back of the heart called the coronary sinus, and that empties into the right atrium. That empties into the right atrium. Oops. Back up. Empties into the right atrium, along with the superior and inferior vena cava. So really there's 3 blood vessels that empty into the right atrium, but they're all bringing deoxygenated blood. Does that make sense? Okay, so now let's look at pictures. This picture and this next one are not in your book. They're from several editions ago with this textbook, but I still like them. They simplify it. Where you see the little fuzzy pinkish red lines, that's meaning it's on the back side of the heart. So you're seeing through the heart to see some of that, which is helpful. Okay, so if we look at the right coronary, okay, that's it right there. There's the right coronary artery. And the right atrium, externally, there's a flap-like structure of it that may overlie some of these blood vessels. And it's sometimes referred to as the auricle. You only see it from the outside. It's just the external flap of an atrium is auricle, like your ear, you know. Okay. But anyway, but there's the right coronary artery, and then the left coronary artery comes off under the pulmonary trunk, and there you see just a little bitty short section of it. Let's do the left one first. Okay, the left one, pretty much real soon, it's going to fork, and the 2 big branches are the one that goes in between the ventricles on the front of the heart. That's called the anterior interventricular artery. The name tells you where it is. So obviously, as it branches, that supplies all of the cells on the front of the ventricles. Okay, both left and right. All right, the other fork of the left coronary goes in between the left atrium and left ventricle and continues on around the back side of the heart. It's called the circumflex. It forms a circle. So it supplies the left atrium and left ventricle as it branches. Okay. Then on the right coronary, it's not symmetrical. It's not short and forks like the left is. It kind of continues all the way around towards the back. So it does for the right side what the circumflex does for the left. But as it does that, its 2 main branches, one goes down the right side of the right ventricle. It's called the marginal artery. And then at the back of the heart, there's a branch that goes in between the ventricles on the back called posterior interventricular. Okay? And so then as blood moves through those blood vessels and into smaller and smaller and smaller ones, it gives up oxygen and nutrients to the heart cells and picks up waste and CO2 from the heart cells. And now that blood moves into the cardiac veins, which we're not going to name individually, but there's just a bunch of them, and they parallel the arteries. But on the very back of the heart, they all empty into the huge one on the back called the coronary sinus, which in turn empties into what chamber did I say? Right atrium. Okay, so it starts in the aorta, flows onto the heart, and then goes into the right atrium. So it can get pumped to the lungs. Okay. So here you can see another view of them. So what would this one be right there? Right coronary, and there's the marginal, and then here's the marginal, or excuse me, here's the right coronary coming along the back, and so that's the posterior interventricular artery. And then there's the left coronary, and it's super short because it comes up underneath the pulmonary trunk, but then it forks into the circumflex, which continues on around, it's hard to see there, and then anterior interventricular. But then on the back of the heart, you easily can see the coronary sinus. Okay. All right, what if there was a blood clot that lodged right there? Remember in the last chapter we talked about an embolism? Maybe an embolism formed and it ended up right there. Or a blood clot just formed, a thrombus just formed there and stayed there. Do you see how that means that none of these cells are going to get the oxygen that they need? Okay, that loss of oxygen is called ischemia, which can lead to a heart attack, which is the death of the cells. Ischemia. Sometimes you hear about silent ischemia is a silent killer, but over time that loss of oxygen leads to death of the cells, which is a coronary infarction or heart attack. Okay. When you hear about bypass surgery, okay, what they do in a bypass is pretty cool. They can get a lot of times they get a vein out of that same person's leg. There's this big old long vein in your leg. Blood can reroute itself in the veins, and so they'll snip a little piece out of this really long one, and reconnect it, and they may attach it then to the aorta on one end, and then all the way past wherever the blockage is. So it allows oxygenated blood to still get to these tissues. Very successful. You can have a single bypass, or it could be in two bypass and blockages in two blood vessels, or a triple or a quadruple. My dad had 5 at one time. Very successful. No, a bypass is different from a stent. What they do in a stent is thread like a little catheter into one of the coronary arteries. That's when there's a blockage in them. Either from usually that's just when it closes up and not a clot. But when they do that, it's called a heart cath. They'll put this little, I think it's plastic. I don't know if that is metal. I'm not sure what the material is. Probably some kind of little plastic or polymer. And it's almost like a mesh, a scaffolding mesh that opens it up and keeps it open. And so that would be not probably for an embolism, but if the arteries were narrowed from, say, atherosclerosis, and it opens it up. And those are very successful too. But if the blockage is so much that wouldn't open it up, then that last course is a bypass. Okay, so let me back up and make sure I got all the terminology for you. I think I did. Yeah, a blockage in a coronary artery, that's ischemia. The loss of the oxygen is considered ischemia. And then the death of the heart muscle cells that's what a heart attack is. And if they die, they can't contract. If they can't contract, the blood can't go anywhere. Okay? So that's called a coronary infarction. Okay. And here's another flow chart that shows what I've just gone over with you. This is the coronary circuit. Okay, so when blood leaves the aorta, the first place it can go to get out of the aorta is through either the right or the left coronary arteries. And then it shows you the two branches of each, the two main branches, and what areas of the heart they supply. But it all pools into the cardiac veins, which in turn pool into the coronary sinus that goes into the right atrium. Okay? That's a big deal. That's a very big deal. Okay. Have any of you ever heard of a famous basketball player from the 1960s and 70s called Pete Maravich? You ever heard his name? Pistol Pete was his little nickname. He played at LSU and then went on to play. I think he was one of the first members of the New Orleans Jazz. That was a pro basketball team that doesn't exist anymore in New Orleans anyway. But anyway, when he was in his 40s, after his pro career, he was just playing basketball with friends, and he died of a heart attack. Very healthy person, always fit. But when they did when they did the autopsy, they found that his heart was lacking a left coronary artery. Whoa. If it was lacking a left coronary artery, it didn't have any of that. But because he was in such, he was healthy growing up, and he exercised a lot, evidently the arteries on the right side continued to grow over onto the left side of the heart, so it was supplied. But he lived longer. That was just a condition he was born with that he was never aware of. But most people who are born with that condition don't live nearly as long as he did. But he was in good shape, and he exercised a lot to develop more blood vessels. So it's sad, but it's interesting. But it had to do directly with this coronary circuit. Okay, that's a good stopping point. When we get back next time, we're going to look a lot at this action of the heart, and look at the electrical activity that triggers the action of the heart. So, in order to understand all of that, it is critical that you know the path of the blood through the heart and naming all the parts along the way. Okay?